Hey, Algebra 2, this is 5.4, day 2 of our lessons, multiply and divide radical expressions or x equations. I highly recommend checking out the Zoom video that we made. Some of your classmates were there, and they asked really good questions, and we did a couple of problems, and we did all the problems of the homework. I'm planning to do the same thing for today, okay? So please, I recommend you popping up into the Zoom, even if you don't feel like saying anything. Being there and being able to have the opportunity to ask a question is going to improve your education. So why don't we just get through this? So 5.4, day 2. The title of this section is called Multiply and Divide Radical Exponents. Well, yesterday we didn't do any multiplication and division, so today is where we're going to tackle that. So let us do some multiplication and division. So I'm about to write a practice problem right now. All right, so I just drew the example. You could pause it to write it down, but I'll read it out loud. 3x to the fifth y to the second over 8xy times 6xy to the second over 9x third power y. Now you're like, Mr. Tobel, there's a lot of things going on here. I'm a little scared. It's okay. You can handle it. What we're going to do first in this situation is just multiply straight through. Let's multiply and combine straight through. Just like multiplying a normal fraction, let's say it was like 3 over 2 times 4 over 5, you just multiply straight through. That's all. So let's do that just like normal numbers. Let's just do it like that, okay? So let's multiply straight through. 3 times 6 is going to happen first. So you're not even looking at the bottom right now. This is dirty sock that I've been using for eraser this whole time. But 3 and 6, we're going to multiply the top only first, actually, okay? So we're going to multiply only the top, all right? So 3 times 6 is 18. Normal numbers get multiplied normally. Next is the combined like term. So x to the fifth times x. Now, that's x to the 1 power. When you multiply exponents, this is a rule from chapter 3 or 2. When you multiply exponents with when you multiply a variable with the same base and different exponents, you can add the exponents. So 5 plus 1 is 6. So this becomes x to the 6 on top, okay? Same thing with y. Y to the second times y to the second. You add the exponent. So it's y to the fourth. It happens to be, so then, yeah, y to the fourth. Let's take care of the bottom now. 8 and 9. We'll do 8 times 9. 8 times 9 is 72. X to the 1 power times x to the third power is x to the fourth power. Y to the 1 power times y to the 1 power is y to the second power. So now we got this. This right here is a chapter 2/3. I got to remember what chapter it's from. But a chapter 2 from 3 question where we can simplify one piece at a time. Just like the normal numbers, you can simplify at the end. We're going to do that for this. So 18 x to the 6, y to the 4th. That top becomes, well, first let's talk about this. Let's do the normal numbers first. So is there anything that could go in 18 and 72 at the same time? Well, I think a whole 18 could get into that. So we're going to divide the top and the bottom by 18. 18 divided by 18 is 1. And then 72 divided by 18 is 4. Yeah, 4. Okay, so we got 1 over 4. X to the 6 divided by x to the 4th. When you have the same base, but you're dividing down, you subtract the exponents. So x to the 6 divided by x to the 4 is x to the second. Because as the bigger number was on top, it'll stay on top. Y to the 4th divided by y to the second, you subtract. So 4 minus 2 is y to the second. At this point, I could box this and I'm done. I can't simplify 1 over 4 anymore. I can't simplify the x to the second anymore. I can't simplify the y to the second anymore. And because of that, we are done here. All right? So let's do another example. This one is the higher elevation of, higher level one. All right, we're on the next one. You could pause the video to write this down. I'm going to read it out loud. X squared minus 4 over x squared plus 4x plus 3 times x squared plus 1, or x plus 1, I'm sorry, over x minus 2. And if you don't see parentheses, the parentheses are implied. All right, so first thing I'm going to do is to go to multiply it straight through. So I got x squared minus 4. And what's really nice about multiplying this straight through is I just literally put them next to each other. x plus 1. I don't want to FOIL. FOILing will make everything complicated. And then over here, the bottom is going to be x squared plus 4x plus 3 times x minus 2. So that's the bottom over there. Okay. Now, some of you guys are going to say, well, Mr. Toba, I see x squared here and an x squared here. Can I reduce that? No. Remember, these things are locked in together because they have the plus signs here. And this has a minus sign here. So this x squared is locked in with the 4. And this x squared is locked in with the 4x plus 3. So you can't do that. Can I remove, well, Mr. Tobo, can I simplify the negative 4 here and the 4 here? No, you can't, because that negative 4 is locked in with the x squared, and that's locked in with everything around it. Can I remove this x and x? No, it's locked in with the plus 1, and it's locked in with minus 2. And you might be saying, Mr. Tobo, you're saying locked in a lot. It's very important to understand you cannot simplify that. I know, I'm going to guess that's an error that could happen if I don't explain it. So I want to make sure we don't do that error. That's very important to me. I don't want that error to happen. Okay, so let us do some math. Now, as of right now, there's nothing the same on top and bottom. So we're going to take this one and try to see. Here, I look at this one first. There's nothing I could change here. But here, your alarm bell should be ringing. Wait, x squared minus 4? X squared minus 4? X squared minus 4, I could rewrite that as x plus 2, x minus 2. Because I remember this from chapter 3. Even if I don't remember this from chapter 3, I remember from yesterday's lesson. So the top part I'm going to rewrite as x plus 2, x minus 2, and x plus 1. I need more space. But yeah, so the top part I'm going to rewrite as x plus 2, x minus 2, and x plus 1. And I can see somebody saying, oh, can we eliminate it? Let's save that to the end. Let's cancel out the end part. Over here, your brain is thinking, oh, maybe I could FOIL it. Like every time I see something like this, we could FOIL. So let's identify what our B and C is. Our B is 4 and the C is 3. The reason I'm breezing through this part is because I explained it in detail in my last lesson. So if you feel like you're lost here, I better see you at the Zoom. And if you can't make it to the Zoom, you better check out those Zoom recordings I post. I don't record it for fun. I record it so you guys could use it to your advantage. So we need things that multiply to 3 that add to 4. So things that multiply to 3 that add to 4, well, there's only one set of numbers that add to 3, or multiply to 3, which is 3 and 1, and that does add to 4. So because it's 3 and 1, I could rewrite this as x plus 3, x plus 1. Something a lot of people always ask, what happens to the x squared, Mr. Tobel? Like the x squared here? The x squared is split up into here and here. So that's why it does x times x. When you FOIL it, becomes x squared. But regardless, let's write this down. X plus 3, x plus 1, and x minus 2. All right. So now here matches the question would be from yesterday. Can we cancel out anything that's alike? Well, yeah, we can. We could cancel out these two x minus 2's. Even though x and negative 2's stuck together, these two are exactly the same. So it's okay to cancel out the top and bottom. Over here, x plus 1 and x plus 1, we could cancel out because they're exactly the same. These two, though, I can't remove this x and x because it's locked in with plus 2 and plus 3, so they're not the exact same. So I just write x plus 2, x plus 3. I simplified it that much. Why would you ever simplify that much? Let's say you have a situation where you have an equation like this. That's really hard to plug in, 10 into all the x's here and solve it. I could just plug in here. If I plugged in 10, it would have been 12 over 13. I would find that easy. Technically, if you plugged in 10 over here, you would also get 12 over 13, which is funny, but that's a lot more work than just plugging into here. That's why the simplification even exists. All right, so this is your answer to that problem. I'll try to give you a full view of it. And then I'm going to pause this video, and then I'm going to go to my final example, division. But trust me, division is not that bad. All right, so we're here at the last question for today, for your examples at least. Again, I cannot stress enough, and I already said it maybe 4 times in this video, show up to the Zoom if you need help. 5.4 part 2. That key CF should feel familiar because we're dividing a fraction. So what happens when you divide a fraction? Well, we don't have a method to divide by the fraction, but we do have a way to multiply. So what we do is keep, change, flip. Hopefully that feels familiar. From some of you guys talking to you guys, that's how you learned it back in the day. So let me use that way. So keep, change, flip means we're going to keep the first fraction exactly the same. So that's 7x over x plus 1. Change means I'm going to change the division to a multiplication. And flip means I'm going to flip the second fraction. So the top is going to be x plus 2, and the bottom is going to be x squared plus 3x plus 2. Now, what is this? This division just became the multiplication. So a division problem is literally just one more step. Keep, change, flip into the multiplication problem. Now we're going to treat it like a multiplication problem. So the first thing I'm going to do is put them all together. So 7x, very important when I multiply the 7x and x plus 2, the x plus 2 is 2 locked in together. So I'm just going to put x plus 2 in parentheses. And here, the x plus 1 are locked in together, so I put parentheses. And the x squared plus 3x plus 2 is locked in with each other. So that's going to be in parentheses. All right. So look at this, and this is exactly the same thing. It's just that the multiplication disappeared, and I put this little extender. Now, with that in mind, what are we going to do? Well, I see from here, I don't have anything to cancel out. I don't have any free 7s. I don't have any free x's. So the only thing I think I could do is factor this, and hopefully I could cancel something out from there. So I'm going to factor this right here. So that's x squared plus I think it was 3x. Yep, 3x plus 2. So let's identify my b and c. Again, I'm going through this because I've done this in detail. And if you don't feel like you're comfortable with this, I better see you in Zoom. So that's 2 and 1 adds up to 3. So you got x plus 2, x plus 1. So I could rewrite this bottom. So 7x, x plus 2 over x plus 1. And this thing is going to be rewritten as x plus 2, x plus 1. So x plus 2 on top and bottom, hey, that's exactly the same. We could cross that out. So now we got 7x over x plus 1 times x plus 1. Now, yes, these are exactly the same, but they're on the same side of the fraction line. Because they're the same side of the fraction line, we don't need to cancel it out. You are 100% okay to write the answer here. And I just want to show you what a slightly more correct answer would be. You will get 100% if you left it like that. But you could rewrite the bottom as x plus 1 squared. Hopefully you guys feel familiar with that notation. X plus 1 squared. So this is totally correct. This is more correct, but both will get you 100 on the test. And I just want to show you to make sure. Okay? So again, I'll take my camera and give you a full view of this whole board at once. And again, I highly recommend showing up to Zoom. I'm going to do every problem and teach it as if I've never taught it, just to make sure we all understand it. All right, you're done, and have a wonderful day.